Only 500 years ago, the universe seemed simple, peaceful, and well understood. The Earth stood motionless at the center. The sun, moon, and planets circled it at no great distance. Slightly farther away were tiny points of light called stars. It was a small, comfortable, and reassuring universe, and man thought himself at the center of everything. In only a few centuries, the scale of the solar system and of the universe expanded incredibly as a result of investigation and study. The telescope and the Copernican theory replaced the Earth with the sun at the center of the solar system. The 5 wandering lights, called planets by the Greeks, became individual worlds. It was believed the solar system ended at Saturn, until the night of March 13, 1781, when English musician and amateur astronomer William Herschel was conducting a survey of the sky with his telescope. He stumbled across an object of uncommon appearance between the constellations of Auriga and Gemini. Herschel's discovery instantly doubled the size of the known solar system and astonished the world. This edition of the Science Screen Report explores the planet Uranus and takes us closer than any telescope ever could as we encounter Uranus with the aid of Voyager 2. Just as the world was astonished in 1781 by William Herschel's discovery of Uranus, so are we 200 years later by the discoveries made by this remarkable spacecraft. Until the time of the launches of Voyagers 1 and 2, only the inner Earth-like planets had been photographed and explored in any detail. Saturn and Jupiter had been only briefly surveyed by 2 modestly equipped Pioneer probes, and Uranus and Neptune were still mysterious points of light in the telescope. The 2 Voyagers swept through the solar system, the planets and its moons a few months apart, and they revealed to us a stunningly beautiful planet with weather patterns more complex than anyone could imagine. The Voyager cameras photographed the Great Red Spot, a storm that has lasted more than 300 years. And here is a sequence of photographs of the Great Red Spot taken through a blue filter. We can see that the storm turns and churns like a gigantic wheel 3 times the size of Earth. The Voyagers found volcanoes on the moon Io. 9 of them were erupting as the Voyagers flew by. The spacecraft also photographed the ancient cratered surface of Callisto. The unusual broken terrain of Ganymede and the smooth icy surface of Europa with its strange markings that look like cracks but are actually level with the rest of the surface. As they flew past Jupiter, the Voyagers also measured the planet's enormous magnetic field, which extends into space for millions of miles. About a year after they passed Jupiter, the 2 spacecraft approached Saturn, which is about 1 billion miles from the Sun. Of course, the most spectacular feature about Saturn is its rings. What looks like thousands of individual ringlets is an illusion. Each major ring is really a continuous sheet of material, but of varying thickness. Saturn's moons were found to be made of water, ice, and rock, and each different from its neighbor. Here is Mimas, which was almost shattered by a huge impact. This is Iapetus, which has 2 faces, one dark, the other bright. Saturn's gravitational field then bent the flight path of Voyager 1 upward, searching for the edge of the solar system and the beginning of interstellar space. Voyager 2 was now aiming toward Uranus, almost 5 years away. A few facts and oddities about the first discovered planet. The Uranian year is long. It takes Uranus 84 Earth years to circle the Sun. Uranus orbits at some 19 times the Earth-Sun distance, where it receives only 1/360th of the solar radiation we do. The surprising nature of Uranus can be traced to the formation of the solar system nearly 5 billion years ago. Our solar system formed an intense rotating cloud of gas and dust, the solar nebula. The sun's nuclear fires ignited at the dense center of this nebula. The planets were born in swirling currents of this great cloud. Planets near the sun, Mercury, Venus, Earth, and Mars, evolved as globes of rock. They were too small in their gravitational fields, too weak to grab hold of the gases from the nebula. But far from the sun, the massive planets Jupiter and Saturn, with powerful gravitational fields, did attract and hold thick gaseous atmospheres of hydrogen and helium. As did Uranus, but with a difference. The deep cold at the edge of the cloud also froze out large amounts of ice, and as Uranus formed, the ice melted into a deep watery layer topped with a thin atmosphere of hydrogen and helium. As a result, Uranus is denser than Jupiter and Saturn, and has a much thinner upper atmosphere and a different internal structure. Voyager 2 also found clouds of methane near the top of the atmosphere. Uranus has a small internal heat source, a partially molten core that is the heart of the planet. Surrounding this hot core is a thick watery layer, but this water is not as we know it on Earth. Here the water is under such tremendous pressure that it displays unusual electrical conductivity. The continuous flow of this conductive liquid creates electric currents, and these in turn generate a magnetic field. Normally, a planet's magnetic field is aligned with the axis of rotation and the center of the planet. Planet and magnetic field usually rotate together, but not in the case of Uranus. The magnetic field is strangely tilted, and it is not centered. This deep internal motion generates an offset field no one has ever seen before. A predicted discovery was a shimmering glow seen over the entire sunlit hemisphere. The phenomenon is an emission of ultraviolet light, which has been named electroglow. Scientists theorize that the electroglow is caused by a stimulation of the extremely thin cloud of hydrogen surrounding the planet. Voyager told us more about the 5 Uranian moons than we ever thought possible, and also disclosed shepherding moons. With the help of Al Hibbs from the Jet Propulsion Laboratory, we can learn more about these moons.
I'm with Larry Soderblom, a member of the Voyager science team. Larry, you've been deeply involved in the study of the moons. These large moons, Oberon, Titania, Umbriel, Ariel, Miranda, those have been known for some time.
Yes, in fact, Herschel himself discovered the outer two just 6 years after he discovered Uranus. And Voyager 2 discovered 10 new moons, too small to be seen from the Earth, but nonetheless they're extremely important. They act as shepherding moons, keeping the narrow rings tightly confined.
One curious thing about the moons of Uranus is that they're all rather dark, much darker on the average than the moons of Jupiter or Saturn.
Not only are the major moons very dark, but the 10 new moons and the rings themselves are extremely dark, among the darkest things that we know of. We think that carbon, in some form, has to be involved in this very dark material.
Okay, well, let's take a look at some close-up pictures of the satellites. This first one is Oberon. That's the outermost of the large moons.
It's a very ancient surface. Notice the dense population of impact craters, most easily visible along the terminator region here. These impact craters tell us that very little, geologically speaking, has happened to this ancient surface, with the exception of a few patches of this very dark carbon-rich material that oozed out of the interior and formed deposits on the floor of this crater.
Next, Titania. This is the largest of the Uranian satellites.
In addition to the abundant impact craters, we see enormous faults that have broken and ruptured Titania's surface. One possible explanation is that water inside Titania froze, expanded, and ruptured the surface.
And then Umbriel, the darkest of all the moons of Uranus. That surface is about as dark as volcanic rock.
Well, Umbriel is a self-contradiction. On the one hand, the population of impact craters suggests a very ancient surface, whereas this bright donut-shaped feature up here suggests a young surface.
Well, unlike Umbriel, Ariel here has a very clear evidence of a lot of geologic activity, judging from that long fault valley, pretty clearly the result of expansion of the interior and stretching of the surface.
At the same time that this faulting and expanding was going on, another process was occurring on Ariel. Here we see something that may be the Uranian version of volcanism, in which a plastic mass of material was erupted out of the valley floors, flowed across, cutting off a crater here, flowing down into these valleys.
It's almost a general principle, perhaps, that as we move from moon by moon closer and closer to Uranus, we see more and more evidence of geological activity.
Perhaps the most beautiful example of that is Miranda. This is the innermost of the 5 major moons.
Larry, I've heard you refer to this as probably the most exotic body in the solar system.
Well, I think exotic is an understatement. Miranda surpassed our wildest expectations. No one possibly imagined what we were going to find here. It's as if geologic terrains were stolen from throughout the solar system, assembled into one object. We've come to understand that Miranda's surface is organized into 2 basic geologic terrains. An old cratered terrain that occupies this region, which has been replaced by younger regions that are characterized by bright and dark bands. This is probably the best example of these younger terrains. The ridges you see here are a couple of miles high, extending about several hundred miles in their length. It appears that fluids from Miranda's interior migrated up cracks and froze and produced them. In addition to these, we find enormous fault systems on Miranda. This has got to be my favorite picture from the space program. Here we see a cliff 16 miles high on this fault. If you were standing here, you could flip a rock off. It would take it 9 minutes to fall to the bottom. The idea of what's caused this geologic activity is that Miranda somehow has been frozen during its early stages of evolution. Normally what happens is a planet, after it accretes, is an assemblage of sort of jumbled up sand and ice. As it begins to heat up, heavier material sinks toward the center and lighter ices migrate toward the surface. We now think that these regions are where those lighter materials were just getting to the surface, but Miranda was frozen at that point, and we have a frozen record of a moon halfway through its early evolution.
The search for shepherding moons was one of the fundamental scientific issues Voyager faced in going to Uranus. Not only did we find shepherding moons, but we now believe they are responsible for confining the rings of Uranus, squeezing them down into their narrow appearance. This photo taken by Voyager's cameras allows us to see dust in the rings. The fact that we are seeing dust is very significant because the atmosphere of Uranus extends into the rings and actually slows the rings' particles down. As a result, the dust in the rings rains down into the planet's atmosphere constantly. Voyager 2's mission to Uranus really began with one man's persistence of vision. William Herschel's discovery in 1781 has led us to the most far-reaching exploratory mission in history, the first survey of all the large planets of the outer solar system.